In this problem, you're implementing two stack operations, push and pop. The problem specification requires that the stack be implemented using a linked list where the head or front of the list represents the top of the stack. Always updating the head of the list will result in elements being added and removed in a last in, first out manner, as we expect from a stack. Let's begin with the push function. The function we've been given has two parameters, a node pointer, which is a node to push onto the stack, and a pointer to a node pointer, which is the head of our linked list. When we push a node onto the stack, we're adding an element to the top of the stack. In our implementation, that means we're inserting at the front of the linked list. In essence, we'll implement a limited form of linked list insert, one that only handles the special case where the head of the list needs to be updated. So, simply set the new node's next pointer to point to the current head of the linked list. To get the head of the linked list, we need to dereference the stack variable. Now we need to update the stack so that the new top, the head, is new node. We can do so by simply changing what stack points to, but remember to dereference the pointer once so that the actual head of the list is being changed. Note the order that we did this. Changing the head of the stack to new node first would have resulted in us losing the rest of the list. Now for the pop function. The function we've been given has one parameter, a pointer to a node pointer representing the top of our stack, and it returns a node pointer, the node that's being removed from the stack. Pop removes the top of the stack, so we'll need to change the head of the list to whatever comes after the current head. And since pop also returns the removed node, we'll need to make sure we don't lose the pointer to the current head when removing it. First, we'll declare a variable to point to the current head of the node, or what we're removing from the stack. This will also be the value that our pop function will return. Next, we need to change the top of the stack to whatever the current head's next pointer points to, and return our removed node. That looks good. Let's run the tests. A few of our tests failed. It seems like we should reconsider our pop function. What happens if the stack is empty? In that case, dereferencing stack gives us null, which is fine, but we'll encounter a segmentation fault when trying to get the value of null's next pointer. To address this, we'll need to add a bit of error checking to our code. We should only change the top of the stack if the stack isn't empty. In other words, if the top of the stack is not null. Let's run our test again.